Hey, good morning, everyone. Thanks, Jamie, for the nice introduction. I'm here to introduce a new product from Dell EMC, Pravega. Just a little bit explanation of what Pravega means. Pravega in Sanskrit means acceleration, speed, and in fact, good speed. What we mean by good speed is you can have crazy speed, but you'll crash and burn, lose stuff in the process. Good speed is when you can maintain the speed in terms of all failures. In our cases, when the machines go down, up, and come up, we still maintain that speed. We never lose data, and that's what good speed is all about. Speed is very important for stream processing applications. In fact, all of us are here today to talk because we all believe in one thing, that streaming is disruptive. And this is changing how we do analytics. This is changing how we write newer applications. And how do you really do that? We want to really treat data as continuous things, as coming continuously, and process the data as it is coming in. That's where speed is very important in terms of how the data is processed and how data is ingested. And that's what Pravega is all about. I'm going to talk about it. But applications which are built on top of streaming need certain special qualities, which means the systems on which we are building it need some qualities. And these are some of the disruptive system capabilities that we need. And today we're going to talk about how Pravega is going to solve this, and also how Flink, in conjunction with Pravega, is going to help us build this new breed of applications. So we all know that we all are here because we believe Flink is one of the best stream processors that exist in the market today, because it does really do stream processing, unlike other stream processing products out there. And we believe that we met the Flink guys a year back from Dell EMC, thought, what is the best storage system that can be reimagined for this streaming world? And what should be the characteristics of such a storage system? And the result is we built Pravega, and in fact, we are going to open source this at our Dell EMC World Conference in May 10th to be precise. So this will be an open source product, because disruptive technologies today are successful only when they are in open source, not closed source. That's what we believe in. And that's why we have decided to open source it. And let's talk a little bit about what Pravega Stream is all about. Just like files, objects, and other things have been fundamental storage primitives in our products, we believe time has come to create Stream as a fundamental storage primitive. Stream is something infinite, it's continuous, and what it provides is, from a storage perspective, to the stream processors, an ability to scale up and down. It gives the clues for the stream process to scale up and down automatically. It provides this abstraction of a continuous append-only log, which is very, very important, and which exists forever if you want to. It's infinite for people to process and build applications on top of it. Also, it provides really strong consistency guarantees and durability guarantees, which are very, very important for building this exactly once semantics, which are inherent in Flink kind of stream processors. We want to really exploit that, and we want to exploit it from the storage perspective so that it is possible for us to even chain these jobs and still get exactly one semantics across these jobs, right? That's why we give a lot of importance to durability, consistency in the new storage system that we have built. Apart from the fact that the streams could be infinite, they are not limited by the space on a single machine, for example, on a single node. They can last forever if you need to. And it also helps to do both stream processing and batch processing with the same storage abstraction underneath. Now, this picture we have all seen before. Some people have given a name called Lambda to it. And this was the result of some of the inefficiencies of stream process and the underlying storage systems that we have evolved into this architecture. And now, if you look at any company or any place, like go to Netflix, for example, if you look at their blogs, you'll see a picture like this. And if you go to Amazon AWS, they'll show a picture like this, that this is the only way to do analytics or do modern pipelines. But we all know from, if you guys are read philosophy, any dualistic philosophies have always been beaten up by non-dualism from philosophical perspective. But coming more to an engineering perspective, engineers have troubles keeping this up and running 24/7 because of so many moving parts involved, because we have to keep so many copies of data all over the place, and just for the fact that use separate systems for batch processing and real-time processing creates immense number of problems in terms of overall productivity and operational viability of such a pipeline. So we all know this, but we are all looking for a solution like this, a solution which looks more like this, right? There is one single pipeline, whether you want to do real-time or batch processing, you can do on this. And Pravega, in conjunction with stream process like Flink, have the ability to achieve this. We are going to talk in more detail about how we do it, architecturally, how we build Pravega at a later session today. I encourage all of you guys to attend. But I'm going to tell you a few things. In this case, both new and old data, we don't have separate storage system for newly arriving ingested data, and then separate storage system for old data. We have the same stream abstraction provided, and we tier the data between these two storage platforms automatically, first thing. Second thing I want to convey is that the streams scale automatically, whether it is a big stream, like an Amazon order. The whole of Amazon orders could be one single stream, or it could be a lot of small streams. Wherever your application is in the continuum, Pravega will work in both scenarios. And in conjunction with something like Flink, which does stateful stream processing, we can do a lot of magic, and we can completely get rid of this Lambda architectures to, for lack of better name, called Kappa architectures, I guess. But getting rid of dualism, that's what is the fundamental philosophical thing behind it. And also the ability to scale everything in the process, the producers, the consumers, and storage system, which has the ability to tell the consumers how it can scale, how they can go up and down based on the load coming in. Because a lot of data that is coming these days is very diurnal in nature, and then the ability to process as the data is coming in, a stream process, we have to keep up with the speed at which the data is coming. Pravega is going to give clues to stream process as to how they can scale up and down. So these are some of the characteristics. We want to cover this in more detail in our session later on. And but that is one side of the story. The other side of the story is that what we are going to build, this new storage system, is going to be the basis for building all other things, a new class of middleware products on top. And this is the fundamental reason why we want to open source this, because we want to evolve this ecosystem. And by the way, Dell EMC is not depending on the revenue of a single product to worry about. So whatever we're going to put in the open source is exactly the product we're going to use. There is no premium product and a free product. Whatever is there in the open source is what we are going to use in our product also. The reason for open sourcing is to build this ecosystem. What I mean by this is, today if you see this dual pipelines that I showed you, at multiple places, data is ingested into some kind of a messaging buffer, pulled from there, and you do some kind of stream processing. Pulled from there, you put in, if you're in a public cloud, S3, or if you're in a private data center products like ECS, then you pull it into EMR, or they put it into some kind of a search mechanism like Elk or Splunk, right? Same data gets replicated over and over again. We want to reimagine that world with something like this, where the cloud storage underneath, with streaming infrastructure, so the ability to do small writes, ability to ingest at a very high speed, ability to process data, and that part's the ingest buffer and streaming analytics with something like Flink. But we can do other things on top of it. We can build NoSQL database, for example. You can build a search engine on top of it. You can build persistent data structure, like the actor model would be a perfect thing to work on top of it, so that it can evolve into a microservices platform also over time. That's why, to really build this ecosystem is why Dell EMC has decided to open source it. And you're going to see this at the Dell EMC conference, which is going to happen May 10th and 11th in Las Vegas. But if you guys are interested, some of you, we can give an early access to the bits because they exist, and all the features that I'm talking about, whether it is dynamic scaling, whether it is transactional semantics provided on top of streams, whether it is the concept of an infinite stream, or whether it is the ability to use the IOPS of your whole cluster as opposed to being limited by IOPS in a single box for a stream. That's why, again, it's a continuum from a large number of small streams to a very, very big stream. We are able to cover all these scenarios because of all these abilities. So all these features, the initial parts are built, but we want to really make it a real open source product where the ecosystem, like the one that I showed in the previous, evolves organically on top of it. That's why we want to release it a little bit early. The first check-in was done on May 10th last year, and we want to release May 10th of this year, exactly. And I would encourage all of you guys to kind of take a look and then participate in this product so that we can build an ideal storage for our streaming world, which is what we all believe in. Thanks a lot.